forward. So with that, I'd like to introduce my friend Christopher.
So it's a bit of my background that I ought to disclose to you before I talk to you a little bit. Before I got into defense technology, I was in humanities. I did my undergrad in English and French literature before pursuing a Master of Fine Arts in creative writing. And then I've spent most of my professional career inside a DoD, so about 2 decades. A small portion of that I was doing humanitarian assistance work in Northern and Western Africa and in Europe. So that's a little bit more about my background. I say that not to make you worry, okay, literature, this means this guy's really long-winded. DoD, this means he's going to have a lot of charts with a lot of wiring diagrams and words. So I challenged myself and I challenged my staff to limit any words on the chart 50, no more than 50 words. So I got 30 minutes. I got 50 words. Maybe next year I can come back and I can cut it in half again. Still on the road there. So, and the reason I wanted to do that is because the topic that I'm here to talk to you about today is really better presented visually by examples than in words. So what you see up here is an image from Shaft Robotics. Shaft is a company that actually won the DARPA Robotics Challenge last year, just about a year ago. They beat out companies like Boston Dynamics. Boston Dynamics was delivering a competing system based on an almost $11 million contract from DARPA itself. And Google, earlier this year, acquired Shaft. Reportedly, Google has absolutely no interest in Shaft or any of the other 6 robotics companies that they acquired having anything to do with the defense market. There's a Defense Business Board report that came out yesterday that seems to confirm this, not specifically to Google, but indicating that many robotics companies refuse to deal with DoD. The reason being that A, the commercial market is so much greater and lucrative for them, and government regulations and IP concerns are really too much of a bother. So Local Motors. Here in Chicago, earlier this year, at the International Manufacturing Technology Show, Local Motors delivered and unveiled the first 3D printed vehicle in a period of about 44 hours on the floor of the expo hall. They printed the components, they assembled them, and they delivered the entire vehicle. That shows what digital manufacturing and collaborative development, which are hallmarks of the Local Motors approach, for those of you that don't know Local Motors, can quickly do and cost-effectively deliver these complex systems. Additive manufacturing is certainly an area that has been growing interest for the Department of Defense. It's an area where technology has really exploded over the last several years. It's not a new capability, but what happened is the patents that were established decades ago expired. And so the technology became available to a broader group of individuals. Big companies, smaller companies, individual technology enthusiasts, and based on that collaborative approach, you see these advancements, these rapid advancements in 3D printing and additive manufacturing. Now, DoD research and development agencies are certainly focused on additive manufacturing, and there are a number of individual initiatives within DoD. The Rapid Equipping Force's Co-Create initiative, which Pete Newell led when he was running the Rapid Equipping Force. Pete's here in the audience, and I think he's going to be talking to you later today. DARPA has crowdsourced vehicles, but the individual crowdsourcing and the individual additive manufacturing pieces are not the challenge. I mean, even the DC Public Library, as of a year ago, has its own 3D printer. So it's not delivering the technology that's the challenge. It's scaling it and integrating it into operations. Certainly there's huge potential opportunities for additive manufacturing to revolutionize things like logistics within the Defense Department, how we deliver products to remote locations. Just imagine what we could do with additive manufacturing in that area. And what about field engineered weapon systems development? There's been a few initiatives, small initiatives, but what if we could revolutionize defense acquisition by delivering field-assisted, field implemented weapon systems improvements so that you can actually engineer that, print your improvements in the field, and do that on a broad scale. So the challenge and the question is, how do we actually scale these initiatives? So let's talk about satellite imagery. The Defense Department has a number of intelligence satellites, a few of them very, very high resolution. On the other side, the CubeSat industry has been blooming recently. Typically many satellites, but typically around a 3-meter resolution. The reason that's happened is lower launch costs, as well as opportunities to collaborate with international partners between the public sector and the private sector on getting microsatellites up into the air. So Skybox Imaging, whom I met with about 6 weeks ago, decided that they wanted to play in the middle. They developed a satellite capability. They have 2 birds in the air right now, using automotive-grade electronics, and they were able to, and commercial components, and they were able to deliver less than 1-meter resolution. So not competing with the high-resolution intelligence satellites that we have, but better than the CubeSats that are out there. Google acquired Skybox about 5 days before I visited with them. And so when I met with them, I talked with them about potential DoD applications. They're primarily looking right now outside of the defense market, not really targeting DoD as a customer. They're looking at agriculture, monitoring crop health. They're also looking at oil and gas, being able to monitor the frequency of deliveries and movement of oil and other products across the globe. They're not looking at DoD. But when I asked them, they said that they would be willing to do business with DoD as long as we don't make their life too difficult. And most importantly, as long as we don't touch their IP. So here what you see is us delivering certainly exquisite systems, but in small number. Now, within the existing, the military space, when we need information, when we need an image in the field, it often takes upwards of 48 hours to get that image if we have a non-priority mission. If we were able to tap into this type of technology, we're not necessarily going to get the same level of resolution that we would, but the frequency of the imagery and the frequency of the availability is something that would change. So, with those examples, what does that tell us? About a month and a half ago, Secretary of Defense Chuck Hagel, talking up in Newport, Rhode Island, acknowledged for the first time really very publicly that the commercial sector is leading the way in areas that are of military relevance. He named robotics, 3D printing, and advanced computing. The Defense Business Board report that I mentioned that came out yesterday, you guys really should take a look at that. We'll actually have a link that you can use to get to it later if you haven't seen it already. But that report goes even further, and I'm going to read a quote from them. They said, DoD frequently fails to exploit commercial technology which is more advanced in most areas critical to military capabilities. So this is a departure from the idea that commercial products can really only provide COTS IT solutions or components, and a broad recognition from the very highest ranks within the Defense Department that commercial capability really is essential to delivering military relevant capabilities. And it's no longer at the component level, but it's at the systems level as well. Now, Defense Research, Development, Test, and Engineering, RDT&E, it's a $62 billion budget this year. Pretty significant amount of money. That includes all of the defense labs within the services. That includes contracted R&D, and that includes reimbursable independent research and development, reimbursable IRAD. So we pay companies $4.5 billion a year to do things on their own that they think will eventually lead to products for DoD. So that's $62 billion. That's just under 5% of global R&D. So if we're focused on only that 5%, we're fighting a losing battle. In 1961, when Eisenhower delivered his famous speech about the military-industrial complex, these numbers were a little bit different. Back at that time, the defense R&D budget was upwards at certain points of 50% of global R&D. But this change to us reverting back to to more like 5% of global R&D. That change in numbers isn't really that recent. It's happened a few decades ago. What's really changed is the availability of technology, the proliferation of access to the benefits of that information, and the availability of systems that are relevant to defense applications. So, for those of you that haven't seen this, this picture was from about a year ago. What it depicts is Syrian rebels showing that commercial technology can be used not only for communications, right? They're not calling somebody up with this iPad, and they're not even detonating an IED with it. They're actually targeting a mortar based on an app that's in this iPad. So our adversaries are using this technology. And they're adapting it very quickly. In fact, that DBB report again, you guys really should read this because it's fabulous, said potential adversaries have easy access to most commercial technology, and they are often agile and able to move quickly to exploit it. Now, if our adversaries and our competitors have this access, we need to make sure that our men and women in uniform and our support personnel have equal access to this capability. So I want to give a couple examples to show how DoD certainly has internalized and can internalize innovation. BJ talked earlier about the fact that there are many innovations that have been delivered within the confines of the defense bureaucracy, of the government bureaucracy. In fact, coming from a literature background, having wrestled through poetry class, and poetry was absolutely not my favorite, I had to recognize that sometimes austerity leads to innovation, right? We tie our hands, and it teaches us and it gives us an opportunity to think of new ways to do things. Potential adversaries certainly have access to that technology. They're thinking that way. Many of our adversaries certainly are operating in very austere conditions. And you all are certainly recognizing that as well. As folks that are not at a commercial innovation conference, but at a defense entrepreneurs forum, I think the inherent within defense and entrepreneurs is a recognition that you're willing to deal with adversity. You're willing to deal with the bureaucracy and the challenges within the government, within the defense industrial base, within the military industrial complex, in delivering innovation, in conducting entrepreneurship in the defense space. And so I applaud you for that, and I appreciate that, certainly. These examples I'll offer here. I'm sure you have many more, and I look forward to hearing about those and providing an opportunity for us to even further exchange those. So back in 2004, we had a not so small problem with vehicle-based IEDs. What we were doing from an imagery perspective was kind of like looking through a straw. We had overhead surveillance, but we didn't see a lot of what was going on around. So we had cameras, we had satellites that were looking in Baghdad, but we could see a very small portion of the space at a time. What that delivered us was a very high resolution image of the blast. What it didn't give us was the opportunity to then play back from the impact and figure out where did that blast come from. So the terrorists were driving these vehicle-based IEDs from one location in Baghdad to another and then exploding them. We couldn't tell where they came from. We could only see where the blast was occurring. So the folks in the field went to the Army's research laboratory and asked them, is there something that you have that could help us? Now the Army Research Lab, ARL, based on their technology domain awareness, based on their awareness of what's happening in the technology space, they said, yes, in fact, we do. We know of a technology out there that could help you. In fact, you've probably seen it. In fact, if you watched Terminator 2 or Jurassic Park 3, you've absolutely seen the effects of wide-angle camera lenses. And so out of this idea was born the Constant Hawk mission. 20 prototype systems delivered, airborne platforms that were tailored to accept the feeds of information from these cameras, from the Constant Hawk systems. What they would do is they moved our awareness from what was on the right side, which was just that soda straw look, high resolution, very detailed but very limited situational awareness, to what you see on the left side. Now, we preserved the ability to zoom in and get the detail when we needed it, but through Constant Hawk, we could have that situational awareness. And through that, we could then back play after the blast and see, where did this vehicle come from? Who was it connected to? We establish the networks, identify the networks, and then deliver something of an unwanted but well-deserved gift to those that brought that to us. So, where did it go from there? Now, this is where we see a bit of a challenge. Constant Hawk, while it was certainly a success in providing that immediate capability, was never programmed for. It was never written into a program of record. There was a competing system that was out there, another program of record called Aerial Constant Sensor, ACS. That program since has gone by the wayside, and Constant Hawk was never integrated into a program. So we have these 20 prototypes, and they're sitting on the shelf. So that's a lesson, certainly. Another example, Spike. Now, this isn't the Israeli Spike missile from the 80s. This is a new project by the Navy lab out at China Lake. The problem that they were faced with was recognizing that increasingly we're threatened by small UAVs, small manned and unmanned surface vessels, and the munitions that we have to combat them, the JDAMs that you see on the left with the F-35, the Hellfire missiles, which you see with the drone on the right, at about a ton and 100 pounds even for the Hellfire, they're overkill. They're more than we need. They're exquisite systems. They're expensive. Not only are the systems themselves expensive, not only are the munitions themselves expensive, but the delivery platforms need to be large. F-35, right? Very expensive program. So what the team out at China Lake decided to do is, with a very small budget, about $1 million, to go out and source commercial components to deliver a lightweight, effective munition, guided munition, against small targets. Land-based, sea-based, they were primarily looking at surface vessels, but also for UAVs, swarming UAVs even. What they came up with was Spike. Weighs about 5 pounds, completely developed from commercial components. It's gone through testing. It's tested to prove just as effective as the Hellfire. They're at about 50% of the cost of a Hellfire per unit right now, and that's without any economies of scale in negotiating agreements with the commercial component providers. All commercial technology, young engineers at the lab, given the freedom and the flexibility that their leadership wanted to give them to solve a problem, and in this case, they ended up using commercial components, exclusively commercial components, to do it. They needed the right culture and the right environment, the freedom to fail, and the opportunity to succeed. Now, the challenge from here is, where do we go? How do we incorporate this into a program of record? There are a number of organizations out there that are looking at this. At this point, we don't have a complete sustainment path, or the Navy doesn't have a complete sustainment path for Spike, but certainly there's an opportunity for that to change. So what we learned from these examples is that we need to link, we need to scale, and we need to sustain these isolated individual innovations in order to fully reform defense acquisition. So Jay talked about the conversation we had 9 months ago. I've got a lot of time left in my career. Many of you have a lot of time left in your career. We owe it to ourselves, we owe it to our country to figure this out. We need to figure out what's out there. We need to maintain that technology domain awareness. You all have it. And the question now is, how do we link that? How do we scale it? And how do we sustain it? So I think of these as islands of innovation. Some of the islands are really small. Some of the islands are pretty big, maybe, Oceania size, innovation efforts within DoD. But there's an opportunity to do more. There's an opportunity to link them, to scale them. Innovation will not survive in a culture that's focused on rice bowls. Innovation at scale is really about connecting with other ideas and resources. So a little bit more about kind of my background. Jay mentioned that I'm director of an organization that reports to DoD's Chief Technology Officer called the Information Analysis Centers, the IACs. I was attracted to the IACs. I came in about 5 years ago as deputy director and took over as director about just under 2 years ago. And I was attracted to the IACs because of the history. IACs have actually been around for 65 plus years. At the end of World War II, the US had captured German rocket propellant documents. And contrary to what you might think we would have done with them, in this case, we didn't decide to lock them up in a vault and make sure that nobody but one person had the combination or the key so that they didn't get into the wrong hands. What we decided to do was put them into the hands of some smart engineers and physicists at Johns Hopkins University and develop what became the predecessor of the Applied Physics Lab at JHU back in 1947, the Rocket Propellant Information Agency. That turned into the IACs that we have today. And the idea was, put this into the hands of somebody, in this case in academia, so who's not limited to only talking about things within the federal government. Somebody who understands the value of this information, the value of this technology, and who has the responsibility to understand who else out there within government, within industry, within academia could benefit from this information. Who could use this information to most effectively develop defense capabilities? I came from the intelligence community before, earlier on in my career, and we had an idea called need to share, right? It was that idea that we're going to lock it up in the safe and we're going to put it away, and the only way you're going to get access to this information is if you prove to me that you have a need to know what's in the safe. After the tragedies of September 11th, 2001, we recognized that need to know was really not our focus, and so General Mike Hayden, who was running the National Security Agency at the time, the NSA, said we need to shift our focus from need to know to need to share. So coming out of that in the early 2000s, I saw the IACs, and that's exactly what I saw in the history. This focus on need to share, or what Mike McConnell, as the Director of National Intelligence, called the responsibility to provide. When I have information, when I know about some technology, whether it's government technology, whether it's commercial technology, whether it's technology that's somewhere else in the globe, I have a responsibility to figure out who could potentially use that and to make that connection. How do we make that happen? Within the IACs over the last 65 years, we've grown more than a little, to the point where we now have, this past year, over 600 active projects ranging from $1 million to $100 million for our largest one that we're actually doing for Admiral Gortonley here, Fleet Forces Command. 7,000 full-time scientists and engineers working in 49 states, doing about $2 billion a year worth of research, development, test, and analysis. There's a book that was released about 2 years ago. Many of you may have read it. It's called The Rainforest by Victor Wang. He actually launched that book here in Chicago in February of 2012 with a white paper. And within that book and in the white paper, he uses the Chicago School of Thinking, blending together social sciences and hard sciences and empirical analysis. And his question was, why does Silicon Valley work? Let me use the Chicago School of Thinking not to recreate Silicon Valley, but to deconstruct it, to analyze it, to understand it. One of the things that particularly resonated with me in that book is a concept he called, from the rainforest, talked about keystone species. Now, keystone species are species in a biological ecosystem that tie the components of the ecosystem together. They're like honeybees and hummingbirds that move from one species to another and actually create that connection between the species. And Victor's view and belief and proposal within the rainforest was that in order for innovation to succeed, you need that keystone species. Not every component, not every member within the innovation ecosystem is a keystone species, but you need that in order to create that cross-flow of information, that cross-pollination that really connects the various disparate components of the ecosystem. So when I read that, and coming from the IAC perspective, I decided at that point that it's now my responsibility as the director of the IACs to really make the IACs into that, to turn the IACs into a keystone species for defense innovation. And so that's what we've been focused on figuring out how to do, and what I need your help in order to achieve. So, how do we do this? I launched and unveiled this initiative called Technology Domain Awareness at the National Innovation Summit in June. TDA is focused on harvesting innovation from commercial and non-defense industries, recognizing and understanding what's out there, like ARL did with the wide-angle camera lens for Constant Hawk, and figuring out how to connect that into Big A, into the big defense acquisition. Channeling innovations in some cases directly from the commercial sector into DoD, and recognizing that in some cases it makes sense to channel those innovations to our large primes that can serve as lead systems integrators and actually apply that technology within defense capabilities. We're not building this from scratch, but linking together these islands of innovation and establishing the IACs as this keystone species. What the IACs bring to this is, of course, our experience with this business model and the network that we've established, as well as the authorities that we have working for DoD's Chief Technology Officer and the customer base that is used to us going out and harvesting innovations and applying them within the confines of typical DoD contracts. So we started already compiling and analyzing technology lessons learned. We've developed a lot of those internally within the IACs through the $2 billion or so a year worth of technical work and development that we actually do ourselves. We've connected into the rapid acquisition enterprise, incorporating and documenting and analyzing those lessons learned from organizations like the Rapid Equipping Force, like the CTTSO, JIDO, DARPA, the TASO, other organizations that have a rapid equipping mission, and being able to document those lessons. We're building marketplace awareness and helping link problems to solutions and vice versa. And we've established, or are in the process of establishing, should be up here within about a month or so, the National Security Technology Accelerator, which is the business end of TDA. Now, this isn't like your typical accelerator where you come in, you go through, and you graduate, and you have your license to do business with DoD. What we envision here is facilities, end-user agreements, technology prospecting opportunities, co-development opportunities, and prototyping using existing and new agreements that the IACs have. So again, being within DoD, we've established a lot of interagency agreements already. We've established a lot of awareness within the technology space, but we need to expand that. And primarily, we've done mostly inside defense industrial base work. Within the IACs, my centers are primarily aware of what's happening inside DoD. What I don't know is kind of Rumsfeld's unknown unknown, right? The companies that are out there that are developing technologies that are not marketing to DoD. They're not marketing to DoD. How do I find out about them? How do I understand the relevance that they have? What if the application that I might have of their technology isn't what their target application is? How do I identify that, and how do I then apply that and get that into a program? So that's the challenge that we have. We're tapping into existing technology initiatives. Many of you may be involved in some of these technology challenges. In fact, in a couple weeks, I'm going to sit for the third time on the Defense Energy Technology Challenge that Tech Connect runs. They do that in Austin every fall, and they also do it out at the Pacific Command out in Hawaii. An opportunity for folks to come and pitch their ideas to members and get feedback and ultimately funding from organizations inside DoD for, in this case, energy technology solutions. Also, exercise insertion. Very important to be able to prove why an emerging technology, why an emerging capability should be invested in. It's one of the challenges that we have that's inherent to dealing with emergent capabilities is you don't have the data to prove that it's better. As much as we might complain about or recognize the failures or the limitations of the systems that we have, do we want to take that leap, and are we willing to, and can we afford to, not in terms of dollars, but in terms of mission impact, can we afford to take that leap of faith? How do we get beyond a leap of faith? Well, technology insertion into exercises is a huge opportunity. Now, that gets at how we view exercises, and what are exercises used for? Is it simply to prove that we can do the job well, or is it to give us an opportunity to actually try something new, maybe fail at the mission of the exercise, but gain some knowledge about our limitations and opportunities to incorporate technology into those exercises and into those missions. So there's organizations out there. There's the Navy mission, the Navy exercise Trident Spectre is a great example. The MAR 4-Pack Experimentation Center that's now transitioned beyond MAR 4-Pack out in the Pacific Command in Hawaii is another excellent opportunity. There's organizations like the REF and the Co-Create initiative that they have. Industry engagements like GIFIX that many of you may have heard of and participated in, SOCOM certainly. And so what we're doing is really further establishing the connections that the IACs have to those organizations and those assets so that we can bring them together, again, within the IACs authorities, within the missions. Of course, awareness and this piece of the access is one of the challenges, but the other question is our contracts and our acquisition process. How do we fix that? Now, I'm not in charge of defense acquisition. The guy that is, Frank Kendall, is actually addressing this. Mr. Kendall, through his Better Buying Power initiatives that he and Dr. Ash Carter, when he was leading defense acquisition and then as the deputy secretary, put in place, the third iteration of that is focused specifically on innovation. It talks about things like accessing global commercial technology. It talks about better understanding what we're getting out of our small business innovative research dollars and our contracted R&D and that $4.5 billion worth of reimbursable IRAD that we're spending money on. Is it even relevant to us? And how are we using it? So he's doing a lot of things at the big scale, and we're providing input to that. There's also the House Armed Services and Senate Armed Services Committee effort at reforming defense acquisition, led by Congressman Mac Thornberry, and he has led this bicameral, bipartisan initiative for about a year so far, and that's showing a lot of promise and a lot of hope. And then, of course, industry organizations, the National Defense Industrial Association, NDIA, and other defense industry. Actually had lunch with one of the senior folks at NDIA yesterday, a couple of the senior folks there yesterday, and we're tapping into that and providing recommendations there as well. What I need is your ideas. We can't just do this within the IACs proper, but I want to serve as a conduit to these organizations, to these initiatives, for your ideas. So, how do we do that? BJ talked about building an innovation insurgency inside defense acquisition. That's actually, I think Jay mentioned as well, that's precisely the concept that we're talking about. Within the rainforest metaphor, we need to be able to connect. And the IACs have the experience and the authorities to make that connection. What I want to do is serve as your platform for your ideas, for the information that you have. Now, defense acquisition reform has been tried many, many times and has met very limited success. So, what's different this time? Well, the fact that all of you are here, all of us are here, tells me that you believe that we can make a difference. And obviously, I'm here because I share that belief. Like no other time, now we have the right combination of demand, with our senior leaders recognizing that U.S. technological superiority is at risk, and opportunity, with the alignment between congressional, executive branch, and industry interests. We have all of that together. So how do we take advantage of it? Again, we're not trying to do this ourselves, and I need your ideas. So past efforts have been top-down driven. Our approach is bottom-up. We're creating the incentives at the working level by understanding what motivates government, what motivates industry, what motivates academia, and connecting to those opportunities, the technology opportunities that are out there. Developing and delivering what we would call emergent acquisition reform. So I invite you and I implore you to join the TDA movement on LinkedIn. You can search for Technology Domain Awareness Initiative, and that'll bring you to it, or you can use this link as well. Connect your ideas into this ecosystem that can scale them and can truly reform defense acquisition. So thank you, and I'll be here today and tomorrow, and I look forward to connecting with you. And most importantly, please join us for this movement on LinkedIn. Thank you.